Hello, everyone, and welcome to this webinar where we're going to talk mapping in a GxP environment. We'll just have a few minutes for the last people to join. We are truly excited about getting started, but let's just have 2 more minutes for the last people to join in. But in the meantime, if you can write where you're listening in from, that would be perfect. It's always really fun to see where people are joining in from. But see you in a couple of minutes when everyone has joined in. Hello, everyone, and welcome. We'll get started just right now. Just for starting out, I have with me my great colleague Marcella here today, which we're going to introduce in just a short while. Just for us to get a little bit better acquainted with everyone in here, we'll just start a small poll here, asking you how experienced you are with the temperature mapping in GxP. So while you fill that one out, so we get a better understanding of how much experience you all have. We'll just slowly get started with today's topic. So today's topic is guidelines for performing a mapping in GxP. And I have with me today for the first time in this webinar, my colleague here, Marcella. Marcella has a ton of experience in our validation team, basically helping our customers with performing mappings of everything from small incubators, fridges, freezers, warehouses, trucks, soon airplanes as well.
Yes.
So she has a ton of experience from the customers, and you've seen a lot of the different problems that could go wrong during the studies. Some of the pitfalls to fall a lot. Okay. Some of the pitfalls that can go wrong during such an exercise, and what to look out for. My name is Jacob, and I'm the head of quality at GxP, and I've been here since the beginning, so for the last 12, 13 years, working with quality on a general level, but also with the temperature mapping, calibration, quality systems, and so forth. Just a very brief introduction why we're here today to talk about temperature mapping. We are GxP. We digitalize and automate a lot of the tasks surrounding being able to pass an audit in terms of temperature compliance. So we deal with temperature monitoring and humidity monitoring, CO2, differential pressure. We deal with calibration. So we have our own accredited ISO 17025 accredited calibration laboratory where we calibrate our own sensors, and we calibrate a lot of sensors each year. We also do temperature mappings and temperature studies, thermal validation studies of various kinds, and do validations. So that's why we're here today to talk a bit about the topic for today, which is temperature mapping. But just before we deep dive into that, I just want to show some of the experience. So it seems like it's fairly close to a normal distribution, I would say. That's really nice. So there's a lot of experience here today. before we get started, please enjoy this as a learning experience. So if you have any questions along the way, don't hesitate to put them either in the questions field on the right of your screen or in the chat. We'll try to take the questions along as they come. But these webinars always get a lot more interesting when we have people who chip in. We can't always answer all of the questions, so use this as a knowledge sharing session and enlighten us. So thank you first of all for that, Paul. The topic for today is temperature mapping in a GxP environment. So first of all, we're going to start out with looking at the overall process. What are the different kinds of steps you have to go through in order to actually get a temperature mapping? And then we'll actually take it step by step, starting out with the protocol, the execution of the actual measurements, and the reporting at the end. We only have around an hour today, now 55 minutes. So we've handpicked some of the topics that we see cause confusion along the way. But it's always important to remember that there are guidelines out there which can help you get started and learn more. First of all, there's the WHO guidelines. It's becoming or has been for a long time the golden standard for temperature mapping. There's the ISPE guideline, and also there's a new revision of the USP, which has some guidelines on how to perform mapping. But basically, we've handpicked a few items today. So
Exactly.
should we just get started?
Yes, please. There's a lot to talk about.
There's a lot to talk about. So first of all, looking at the mapping process. If this is something you've done before, this might sound very familiar, but just to get on the same page here, one of the things we often see a bit of confusion on is where does mapping even fit in terms of validation? So it's important from our perspective. We've always seen it as you're validating your process, and your process is to store goods, typically store goods. It could also be freezing or intermediate storage or transport, whatever it might be. And in that sense, mapping comes into play in terms of qualifying both operationally and performance-wise. So often, as a rule of thumb, we would normally say that the operational qualification is the empty stability studies, where you ensure that your facility or your equipment, whatever it might be, is able to handle and control temperatures within the acceptable range when it's unchallenged. So that basically means we need to ensure that the facility out of the box, or I don't think large warehouses come in a box, but but fridges and freezers do, at least, that it can actually operate as it should. And then the performance qualification is often when you try to simulate how this is going to be used in a process, and how challenging it with power failures, with door openings, whatever it might be, seasonal changes, that it can still operate within the acceptable ranges. So taking that a step further, the mapping process can be broken down into 3 steps. We'll have the mapping protocol. That is where we outline what the requirements are from your V model. You can use that and from your user requirement specifications. What does this process actually need to comply with? What are the requirements for this process? What is the temperature range, door openings, storage, all those kind of different items that are interesting to your process. Speed at which, how quickly it can handle changes in outside temperatures and so forth. And then we define the test methodology. So basically, how are we planning to test according to our requirements? Then we have the test execution. So that's the real interesting part, and I know you have a lot of experience in that as well.
Yeah.
Where we actually go on site, get the actual measurements rather than being in our comfy office. We'll actually have to go on site and be either hot or cold or hopefully not wet, but at least getting
Not
out there in
yet.
reality. And then the reporting phase, where we conclude on all of our findings. We look at the data, we compare it to the results. And those are the 3 steps that we'll go through today. So first of all, I would love to start out with the protocol. There are a number of things that should be included in a protocol. There's a lot of, you should say, can sort of say standard items like an author, a reviewer, signatures. We're not going to go too much into details with those things, but some of the important things are, first of all, a place where we see a lot of customers failing in order to understand what their requirements are, is basically to write down your acceptance criteria. And the reason why this is important is, first of all, we don't know what to test against if we don't know what the acceptance criteria are. So one thing is that you might have a general understanding of what the requirements are for an ambient storage, but you also need to apply your product knowledge. So the products that you store, what thermal mass do they have? How big are they? What temperature ranges are they suited for? That needs to play into role as well. We've seen tons of cases where customers said, well, it should just be an ambient storage and that's it. But auditors love it when you can explain, well, it's ambient storage because we plan to store these and these and these types of products, which are rated for X, Y, and Z. Then you need a good process knowledge. So you need to have a good understanding of how you do your process surrounding storage, basically. But also that means, for example, how often do you plan to open and close your doors? What kind of exposure is there to the outside elements? Do you take in goods that are already thermally at the level where they need to be, or are you using it to freeze in stuff? And then you need to have a really good understanding of your facility or equipment. How does it operate? I think a very good case is like defrosting cycles, something that often comes as a surprise.
Yes. Many problems come for that because all the HVAC systems have defrosting cycles, and then we see excursions through them, and sometimes people they don't expect to see that. So, so we do need to take them into considerations. And maybe this goes into the accepted excursions, that once you know your product, you can think about the excursions and the type of facility or equipment you want to purchase if you're building one.
Exactly. Yeah. So having a good understanding, like it does not make sense to do an acceptance criteria that is, we can have no excursions if you know you're going to have a defrost cycle, for example. On the other hand, if you know that you have very strict requirements for your process, thereby also your product, well, it also means that you need to purchase certain types of equipment, right? So this is an example of how such acceptance criteria can look like. It's very simplified, but basically it works that you have a lower limit and a higher limit, and you might also have allowance for shorter excursions, and you can even identify for how long time and for how much excursion there could be. It really depends on how critical your products that you store are and how sensitive they are to time and temperature. The next thing that is really important to identify in a mapping protocol is basically where to map. And we've seen several cases of as well where, well, we choose to map the entire facility, even though we don't store products at the entire facility. And the small illustration here on the right is basically an example of, well, first thing you need to do is to identify where do you plan to store any products, either temporarily or for longer periods of time. So in those areas, you need to perform temperature mapping. And we often refer to this as the usable volume. So basically, you have your facility with the total volume, but which parts of that facility are you actually going to use for sensitive storage? And once you've identified those areas, we've developed a model here in GxP in which we look at 3 different types of risks. We look at compliance risk, technical risk, and operational risk. And there are a few examples of these, but in general, in a general sense, you could say that compliance risks are related to whether you follow the standards and the guidelines on the topic. Do you deviate for those or not? Technical risks are referred to as risks that are related to technical installations, for example. That could be doors, gates, windows, but also forklift chargers is a known culprit, right? It doesn't generate any heat during the day, but when people go home, they put the forklift in the charger and it starts generating a lot of heat. Hydraulic lines, those need to be identified as well. And then we have operational risk, and operational risks are can be a bit tricky because they are really related to how you use the facility. And if it's a brand new facility, you might not be absolutely specific on exactly how you plan to use the facility. And therefore, that means how do people enter and leave the facility? Where do goods go from? There might be a loading bay. Do they go directly from the loading bay to long-term storage? That might be less of a risk than if you have intermediate storage. Do you have areas where there's a large volume of people at some points during the day, and then at other times during the day it's not as much? All of those things need to be identified because they have an effect on where we place sensors, and they have an effect on how we plan out the test methodology. So we just have a few questions here. So there's a good question from John saying, does this also measure dead space? So that's a really good question. If I understand your question correctly, when you identify the areas that you store, you also identify where you don't store, if that's meant by dead space. Basically, what it says from the guidelines is that you should monitor at all positions where there are products stored. So often it comes down to a discussion of, well, if you just have goods moving through an area relatively quickly, do you need to map that area? And often the question would be, the answer would be no. But then again, are people tempted during the operation to leave something behind just for a little while and then move it onwards? Well, then becomes a bit of a greater
always
risk.
good to have one data logger measuring
Yeah.
the dead space.
Fantastic. So moving just a bit on here. So when looking at sensor placement, this is one of the sometimes the hardest thing to learn, but also when you learn it, you think, well, why was this so difficult to begin with? I don't know if you can agree.
I agree.
Yeah.
At first, it seems very complicated, but once you understand how it works, it becomes really easy.
So
and kind of fun.
And kind of fun as well.
Yes.
Yeah, I agree.
To do the placement.
So when placing sensors, there are two approaches basically to choosing how to place sensors. The first one would be to follow the guidelines, which have recommendations for how to place them, and they would often say you need to place them in the corners of your volume, the center, and different heights. You need to place them close to windows or temperature control sensors. What we see being more important for auditors these days is that if you understand the underlying risks that those recommendations were based on, you're way better off in rationalizing where you place your sensors, and you can actually communicate why you chose one position over another. So the typical sensor placement risks, or the risk we're trying to mitigate by placing a sensor and actually measuring the temperature and or humidity, are first of all homogeneity and stability. So in any space or volume, there's going to be a difference in temperature of two different places, no matter how close they are to each other. So the first risk we want to avoid is that the temperature is not the same at all places, and that the temperature is not stable, so flatlining basically. So first of all, we're going to place sensors in the corners and then in the center of the volume. So that will be in a 3D space where a cube has 8 corners and one in the center. That's the most basic way to place sensors. And often you'll have to place sensors at certain distances in length and width and height. The guidelines give different guidance on exactly how far spaced they should be, but a good rule of thumb is that there should always be at least 3 sensors in any dimension in height. If it's not very tall, you can get away with 2 sensors, but 3 sensors, but 3 sensors in height and or in length and width. I don't know if you've seen any other good recommendations, or what do people typically use as a reference for how far spaced sensors should be?
It really depends on the size of the facility, but usually it's every other row at least. We can skip 2 rows depending on the size, but it really depends. As long as you keep the kind of symmetry between the whole facility, we can work with every 2 rows.
So the other thing, the other risk that we're trying to mitigate is basically a technical risk. So whenever we have any places where we have doors or gates where there might be an ingress of non-conformant air, we need to place a sensor. Not always at every single door, but at least at a representative number of them. As well, we see it less and less, I guess, with LED lights that are not generating that much heat compared to older lights. But basically, also lights can also be sources of heat.
A lot,
yeah. And there's also typically a lot of lights, right? Yeah. And then at HVAC airflow, so when you have the outflow of air or controlled air from the HVAC system, that air in itself might not be within the acceptable ranges, because if you're trying to cool down a large facility, so the air is likely
really cold.
Yeah.
The exit will register that.
So the position where the HVAC air hits your product, you need to store, and yet again, there are typically several exits of HVAC air, and you need to take a representative number. We also have a lot of often like heat generating equipment. We mentioned before hydraulic lines as an example, but it could also be forklift chargers, any type of equipment. We also need to place a sensor where there should be product, but closest to the heat source. And then, of course, we have external influences, which could be a room connected to the room you're trying to map, or in the case of a fridge, for example, the surrounding air. But it could also be for large warehouses. If you have a face or a wall facing the sun rather than one in the shadow, that can be an external influence that you need to take into account, which we'll also get into at a bit later point in terms of seasonal mapping.
And that's really interesting because we usually are so worried about the gates and doors that actually bring outside air that we many times the customers don't understand why do we need to place just in a wall.
Yeah.
And it's because of that many times it heats the surface, and then this heat may affect the product. So we do need to
and is this a quality mindset speaking, or does it actually have any practical implications? I mean, do you see changes?
Yes, you touch the wall and then you feel the difference. Yeah.
Okay. Oh, really interesting.
Again, depend the size of the facility. All of them are different. So.
Yeah. I guess that's also one of the things you get with experience, right?
Yeah,
Is you
yes.
determine. So, and the last thing where we need to place sensors in order to mitigate risk is operational risk. So that could be through doors and gates, where you actually try to challenging them by opening the doors, and not only opening them, but also identifying for how long time can you actually hold the door open for. For a freezer, this is very, it has a large impact, right? I mean, you basically take 1/4 of all the surface area and you open that up.
For sure. Yeah, because once you open a freezer, the whole air is renewed. So you need to think, and that's quite tricky because the customer needs to think about, okay, I'm used to open this door, look inside of it, and take something. But how long do you keep the door open in normal operation throughout the day? How many times do you open the door? So this all needs to be thought about. So we can work with that information.
Absolutely. And then what we briefly touched on before as well, temporary placement zones. Like, no, and I guess I've heard that many times at least, that the quality person or responsible will say, oh, we don't store any goods here. But then when it comes to actual operations, well, you might actually store something, right?
Which make a lot of sense. Once you are unloading a truck, you rarely will take everything that is inside the truck and put in the long-term storage. So you put somewhere in pallets probably, and then afterwards you probably identify and organize in your own system, and after that you will put in the actual shelves. So it does make a lot of sense to place loggers on that space.
Absolutely.
That sometimes may sound as a dead space, like he mentioned, but it isn't actually.
So this is just an example of what such a mapping strategy could look like. So this might look overwhelming, but basically at each of these points, we'll have a dot representing that a sensor needs to be placed there, and then a number next to it, meaning how many sensors on top of each other should we place. So we'll often work with in protocols that we have our rationales in place. In other words, a description of why did we place this specific sensor right there, which type of risk did we try to mitigate using this sensor position. So we often work with 3 different types, and you can have on and off how many, but basically the most basic one is grid, and we often denote that by a G. So this is all the sensors that have a G next to them are placed there because it just covers the volume that we're trying to map out, right? It's placed in a grid, so it's a grid sensor. Second of all, we'll have doors and gates. So by placing a D next to the position, we can see, well, we saw that there was a door or gate at this position, and therefore we need to place a sensor in order to test out whether the door or gate has any influence on the conformity of the temperatures. And then lastly, airflow. So you'll see those in front of HVAC systems. Now this is an imaginary warehouse. It looks rather nice and rather simple, but basically whenever you have blowout air from the HVAC system, you should have a sensor placed right next to it. And that becomes really important when we get to the execution stage, right? Because that allows us to communicate to the person who's setting up the sensors, why should I place this sensor here? We can never millimeter by millimeter describe exactly where a sensor should be, but we can give the line of thought to the tester in the real world, right?
Yes.
So when you come to, and you know this from a ton of experience, Marcelo, when you get to a place and there's a dot on a map and you're trying to figure out exactly where is this in the real world, it's nice to have that line of thought from the author of the protocol, right?
For sure. Yes. That's why not always the person that is writing the protocol will be the one doing the execution, but frequently we have meetings to talk about the placement and how we should approach it. Yeah, that's mandatory from my point of view. Yeah.
So we have a question here by Dinesh saying, please mention the size of the room. Well, this specific drawing is an imaginary one, but yeah, in the protocol, you should have the size and the layout, the insulation material, everything you can in the protocol. As I mentioned before, we don't have unlimited time. We could talk for hours, I think, on just this topic. But in general, you should have as much data in order to be able to verify that the test method was appropriate for the testing methodology that you actually chose. So when writing the protocol, you're also communicating what did I want to what kind of design do we see, and what would be a good test methodology in order to mitigate the risks related to this as well. So one of the other questions we get, and there was also a previous question here, changing seasons, is the test strategy, right? It's I guess in that balance between the business needs to get started and getting the whole thing over with, and also being sure that you have a high level of assurance that that everything is working as it should. So there was just a small question here regarding the last slide. What would the number represent in the diagram? So that's basically how many loggers you would place, and often you'd have more information related to so if there's a number 1, it's just a single logger. If there's number 3, there's 3 loggers on top of each other, but they're in the same width and length position, basically. This is overly simplified. But moving on a bit here. So it's very clear from the guidelines that you need to perform summer and winter mappings if, and there's a big if those have an impact. So a great example of
for equipments inside controlled rooms, controlled temperature rooms, you don't need to do that. You can map once in the year if you're gonna keep that temperature all the time.
Yeah, and why not? What is a good rationale for not doing that?
Because there's no influence of the weather in the equipment that you're using. Yeah, but for facilities, it's needed.
Yeah, so basically, if you have any type of external influences that are basically ruled by the weather, you'd need to perform summer and winter mappings. And this is what a typical mapping strategy could look like. So there are different methodologies, and I think there's about as many different ways to do this as there are validation engineers. But this is a strategy that we often see employed, which is, let's say you're starting up your facility during summertime. Well, you'll start out during the summer, and a good question is when is summer, but often you can't get the exact hottest date of the year to do this, but as much summer as you can. You'll start out with an empty study where you would start out with performing what we call a stability study. So that is without influencing the facility, just leaving it alone for something like 7 days in order to catch all the small variations you would get during such a stage. Then performing a power failure. If you don't have any backup systems, what does it mean if you have a power failure? Well, you need to study that basically to give you information on how fast you need to respond in the case of a power failure. And then you do door openings, simulating length and duration of a number of door openings during either as a fridge or typically for a warehouse. Then you'd make a full study. And I guess there's often a confusion about, well, do we need to store actual products to do a full study?
Yeah, you don't. You can use what we call dummy goods. That there are many different types, but it could be basically card boxes or any kind of boxes or tarps that just will work as an obstruction for the airflow, because in the real life that's what's gonna happen. Your product will stop the airflow through the shelves. So it's just important to simulate that.
Yeah, and how would you simulate if it was like a smaller unit, like a fridge or freezer? Then
It could be also boxes, like polyester boxes or card boxes or bottles. If it depends also what they're gonna store. So it's really nice to have something that would be close of what you're gonna actually store in that unit, but it could be a large amount of different things.
nice, yeah. So challenging and doing the same study again, having a stability study, basically how does it operate in stable environment, power failure or door opening. There are tons of considerations to go over in terms of choosing a good strategy. Often we would see that, well, a full study with the power failure and door opening is not necessary, because you can rationalize your way out saying, well, it's most critical when it's empty, when there's nothing to keep the cold in place. But that's a topic for another day. But this is the general guidance from the different guidelines.
I agree, it's a topic for another day, but this is a question that pops up a lot. There's a clear difference when you see graphs of temperature mapping in empty and full, and it's important to understand that the load, the products, they work as a buffer. So actually they hold the temperature. So the empty scenario is the worst case scenario that you can have in your facility or your equipment. So it's
there's that large of a difference often.
Yeah, it happens, especially during door openings. You see how different it is. Yeah, the door openings are always worst in the empty units in general facilities as well.
Okay, cool. Yeah, and then comes the other season. So basically, if you started winter, then you go to summer or vice versa. We're seeing there are basically two different strategies. One is performing all the studies with empty and full, all the different studies again, but we're actually seeing generally good auditor and governmental acceptance that you would map during a normal operation. So basically performing the summer mapping and then starting operation. And then when you get to winter time, you will basically do a study with all the sensors in place, put up all the sensors again, and doing a study for a prolonged period of time, because you can't control exactly what different scenarios there are. So often you would extend the mapping period in order to get all the differences. And that leads me really nice to your question, Lloyd. Are seasonal studies necessary when real-time monitoring is employed? A really good question, but the key point here is that in a typical scenario, you would have way more sensors, way more monitoring points during a mapping that you would do during normal monitoring, ongoing monitoring. So what we need to ensure is that the space between the ongoing monitoring sensors are also within the acceptable range. So in that sense, yes, you do need seasonal studies, but there are other, and we have other webinars on continuous temperature mapping where you basically leave all the sensors in. And in that case, well, you don't need to. I would highly advise on going and watching our webinar on that topic, and we also have an upcoming one. But I guess it's also about being extra diligent in the time from your first mapping until your next one, right?
Yes.
Yeah. Being extra careful that you don't see any excursions that you didn't plan for.
Yes.
Yeah. Great. So moving on, now actually getting to the work where we're actually going to get...
I was chosen to talk a little bit about execution, but I would like to highlight what Jakob already said. It's very important to have really clear communication during the protocol phase, because everything that comes after the protocol will reflect what was planned, and all the communication that we do, everything that we ask to write the protocol is really important. So as much information the customer can provide, like pictures of the facility or the units open and closed, and floor plans and maps, everything helps, because many times the customer is so used to the facility they already have that they don't actually think that it might be important to say that there's a normal light on top of all the products. And then when we get there, we realize, we need to put more top positions because those lights generate heat. So the execution many times goes very differently from what we plan. And I can say I've done many mappings on site and remote. And what I can say, there's no statistic on it. I never did it, but I can say roughly 80% of the times that we go on site, we don't see what we planned for in the protocol. It happens a lot. So we do need to be flexible and talk a lot with the customer on site to understand what are the actual needs, so we can reposition some of the data loggers and cover as much as the risks that we are seeing on site. Jakob already mentioned most of the risks, but there's many. It happens many times that we go there and we cannot reach that position that we plan in the protocol. And the protocol was approved by the customer, so they saw that there, and they didn't realize that we cannot reach that position, so we cannot put the data logger there. So it happens many times that the facility may have a rooftop window and the lights that I already said that produce heat, the windows are not protected with sun film, for example. So the sun that are coming in are actually hitting the products, and many charger stations as well. So all of this will reflect in changes on the report. And when we go on site, that's fine that everything is different. What is the most important for us is document all the changes that are being made. So the protocol, it's not a document standalone. There's a lot of documentation appended to the protocol, and we call them test plans. So each different kind of test, stability test, door opening test, power failure test, comes in a different documentation. And all of them, there's an area where you can write everything that came differently. So we do need to register everything. So when we write the report, we have a timeline, a train of thoughts that makes sense and connects everything. That's the most important thing by the end. So it's okay to have the changes and not being everything
you shouldn't
exactly
feel bad as well.
No, it happens all the time, but we do need to be careful with that. And something that we always do is do the picture documentation. The picture documentation is important not only to show where the data logger was placed, each one of them, each of the positions, but also to reflect the load in the whole facility, because there's also in the protocol a section that we describe the amount of load that the facility has. But this is changing all the time because things are coming in and coming out. So we do take pictures to put in the report that during that time, that was roughly the amount of goods that we had in that facility. Yeah. Another thing that's really important is that when also, besides noting out everything, we need to register who did that and when it was done right on time. Because then we don't, like I said, we don't need the track of everything that we need to assess in the report.
Is that often something that's missed, like who and how and when?
Yes. We are human, so everybody makes mistakes. It comes from all the sides. A lot of things happen on site. We need to prepare a lot of things. It's also really important to plan how we're going to get to the facility, in the sense of, do we need safety equipment, safety shoes, harness, helmets, vests? Do we need a training to walk around in that facility? So all of this comes from the communication that we had previously. And that phrase really gets me. If it isn't documented, it didn't happen. If you have an error, like you just mentioned, you can understand. You see by the document, especially with time, you see when something was an error or it was just something completely wrong. So errors happen, and we can always assess them in the report as a non-conformity, and that's fine, as long as you can find the track of it. Yes.
So again, just interrupting you here shortly, there's a bit of a question here, basically from Tian. How many percentage is full storage?
It depends on your facility.
Yeah.
Yeah, we cannot. It would be very easy to say it's 100%, but
Yeah.
many of the facilities you cannot load to 100%. So it depends on which kind of product that
Mm.
you are putting in there, and the facility itself.
Mm. And there's another question here, or a comment from Hector, saying normally we address changes to the plan with deviations to the protocol, where you perform impact assessment to the initial plan.
Yes.
Yeah. Do you agree?
Yeah.
Yeah. Yeah.
Yeah,
Perfect.
that's true. We assess with deviation. So there's a bit of I wouldn't say confusion, but a discussion in which kind of terminology should we
Mm.
use. If it's non-conformity, if it's deviation, if it's excursions, there are a lot of conversation in that area. So it's according to your process.
Mm.
If you internally you call this kind of differences between the protocol and the report deviation, it's okay.
Yeah. It's okay. Great.
Yeah.
So,
Yeah. And the reporting is the fun phase.
yeah.
It's the last phase.
Yeah.
And it's the part where we put the puzzle together. And
Yeah.
it's quite interesting to work on that because
Mm.
it's like I said, you follow a train of thoughts of the things that happened, and then you just need to have them all on paper.
Mm.
And it's quite challenging as well. So at first, I always like to give my customers a preliminary graph. So when I do an installation of the data loggers on site, I leave that place and I let the stabilization time run. That's the period where all the data loggers will sync into the actual temperature of the unit or the
Mm.
facility. And after maybe a day, I send them a preliminary graph where they will see how the temperature is working
Mm.
through that period. And you can have this kind of graph, for example, that
Okay,
you
so can I interrupt you with a question? So would you include that
yeah,
preliminary
right,
research?
preliminary graph.
Would you include that as part of the mapping report?
No. The in the report we have the graph for the whole period that was
Mm.
mapped. The preliminary graph is just a way of communicating with the customer, because then you will have a few options. If you see that you have some excursions, like in this case, the green area is the acceptance criteria, and the red area up and down are the temperatures that are not allowed. So once you have deviations, you show the customer, look, those positions are going outside the range. How do you want to proceed with that?
Mm.
They have a few options. They can pause the project and act
Mm.
on the risk, and understand what is happening and fix what it needs to be fixed. Or they can say, no, that's fine, just go, let's go further. We will write the report, and then we will use this report to assess improvements, create processes inside our company, and then we will improve afterwards.
Mm.
It's just something that the customer prefer to do. It's
Okay.
their choice.
So you would often get the data out of the wireless sensors and just follow along and see
Exactly.
whether everything is roughly as it should, I
Yes,
guess.
especially if it's for many, many days.
Mm.
It's very good to follow the data while it's going, not only wait 14 days and then by the end we will check how it
Yeah,
is.
yeah.
That's not doable,
Mm.
and it's not good for anybody.
Mm. Yeah,
Yes.
great. So moving on a bit here in terms of now we sit with we have in hand, as you mentioned, we have the data, we have all the filled in test plans, we have all the documentation we need, and one of the things to look at are non-conformities you mentioned before, excursions, deviations, whatever you call them, anything that didn't go as per the protocol. And as you said before, I think it's really important to state that it's okay. It
Yeah.
happens all the time. No one's
Yes.
perfect.
No.
Until we get robots in to do the whole
Yeah.
thing, there'll still be issues.
They will hit the place, so don't do it.
Yeah, exactly. Yeah, but the important thing here is basically to review those and assess whether they have any impact on the results, right?
Exactly.
So what would you say? What's the most typical nonconformities we see actually? What are some great examples?
Oh my God, it just slipped my mind. But let me think.
I guess we often see stuff like data loggers that have been removed, for
It
example.
happens
Yeah,
a
yeah,
lot,
yeah.
especially in normal operation. It's
Mm.
very common that the forklifts, scissor lifts, they may crush the data loggers because
Yeah.
of where they were positioned. It happens a lot. They can be removed by someone that was not advised
Mm.
about the mapping. So this is another thing that we also talk about. Like, let's put some signs to tell
Mm.
people that we have a mapping going on.
Mm.
We we do have this documentation as part of the test plans as well.
Mm.
And
But I guess, and often we'll also see a loyal thing you like probe failures if something
it
broke,
happens,
doors that have
yes.
been opened without they should
Yes,
have been
many
opened, or been
times.
opened for too long or too short, whatever it might be. The really crucial thing here is basically just to look at how does this impact the results that we're going to write in the report. If we're missing a few data points, does it matter in the overall picture? Does it really have an impact on how sure we can be about the results that we have? Do we see any deviations in terms of where the loggers were placed? Did we actually mitigate all the different issues? As we mentioned before, there might be areas that are impossible to reach in reality. Did we place a sensor right next to it instead? And can we still trust those results? All of those assessments of all those nonconformities needs to be documented, and you need to document the rationale behind choosing whether it impacts or does not impact your result. So this is one thing where being sort of pinched in between operations and the quality, you have to make an objective decision, and you have to make an objective decision based on some scientific standards. So basically, does it really happen? I mean, if you're missing 1 hour of data in the middle of your study, is it realistic that the temperature went way out of excursions or whatever it might be?
Yeah, in
Mm,
case of probe failures that
mm,
Lloyd just mentioned, we can always replace them. Of
mm,
course, it depends where is the on-site,
mm,
but if it's in the city that we are and we are waiting for that mapping to be finished while we are in the city, we can go there and replace.
mm.
We
Good
always
point.
have extra ones. So this is also something that we will address in the report because the initial probe is not the same as the final one, but it is also doable. So
Mm,
this is very common actually that we have.
absolutely. And then getting to what I think everyone is waiting for in terms of when you want to hand in the report, what is the conclusion? One of the things we're often discussing with customers is basically there's often a desire. We discussed this earlier. The desire to either have it's a good to go or it's not good to go.
Yes.
But that's not really the point here. You shouldn't. You should really try to avoid having these binary conclusions saying everything is fine or everything is not fine. Often what we want to communicate using a mapping report is that there are areas of risk and there's areas of high risk and areas of low risk. So if you find that the temperature is highly deviating in some areas, it might be acceptable or might be not acceptable. You might have areas that are acceptable and not acceptable. So rather than stating that the entire facility is out of specification, well, basically you can state that certain areas are within the acceptable range. And another thing we used a lot of time before we started today discussing is the mapping report is pretty much a future improvements document, right?
Exactly. We are providing a lot of data, and nobody would like to be stuck. Like
Mm,
we are not here just to give you a stamp, like it's approved. No, you can use the data, study your facility according to the products that you have in it, and evolve from there. And I do agree that's
mm,
the most important thing, part of the mapping. It's
absolutely. Um, So that basically concludes a bit of
right.
what we had today, and we have a bit of time for reaching up on the questions. We'd just love to throw just a small poll out there as well in terms of how what you see as the most problematic during your mapping. So whilst we go through the questions that were collected, and you're also more welcome to writing in some more. Um, we have a question here from Masud. Does two-season mapping necessary for cold rooms and freezer rooms which are not impacted by seasonal temperature variations?
If you're sure they are not impacted, then no, you
Mm,
can do it uh, once, and then in a few years after, or anytime you have any kind of improvement, if you change the HVAC system or if you do any improvement in the area, but it's not necessary every season.
And how do you assess whether it's actually affected by seasonal variation?
Yeah, if it's a cold room, it's probably inside another room. So what is the temperature of that room? How is it controlled? So that's the questions that you have to answer to get to that.
Okay, so it's really much about looking at the design of the facility, and whether there actually is a temperature control system between
Yes.
the internal room and the actual outside walls, right? And I think we also do see some cases where,
Can I just
yeah,
add one thing? But at the same time, it's really important. For example, you have a cold room, so it's 2 to 8, and it's inside a room temperature facility. But this facility has gates, and these gates are close to that room. Then and you open the gate of the cold room for the facility. So in this case, I think it's good to do a risk assessment, because it may be possible that you need a seasonal mapping in that room.
And that might also be a great point from here then, that you need to be able to document for an auditor that you've done those risk assessments,
Yes.
and why you've chosen to do or not to do seasonal temperature mappings. So there's another great question here from John. Do you ever consider a staging area for samples or items pending transport in out of a chamber? I guess
It
the question here
happens.
is basically, do we need to map those areas if we have an area that's just used for intermediate storage?
Yeah, I have mapped areas
Yeah.
like this. Yes, especially if it is a temperature not long-term storage area, but for how long? How long you're gonna leave your products there? So you have to take this into consideration, because sometimes the whole day, and then you need to know which temperature it reaches there.
Another great question here from Julio. At what stage do we challenge the process equipment design specification? For example, the freezer can reach minus 30 Celsius by design when the required product storage temperature is minus 10 degrees Celsius. So I would say often doing if you have equipment that is where it's very critical that you have a design specification where it needs to go below where you need to be, that will often be either doing a user acceptance test when you get the facility on site, or doing an installation qualification. And sometimes we see it being performed as part of the operational qualification. Often though, we do run across cases where the equipment and the mapping protocols are designed in such a way that they test the entire operating range of the equipment, and that's often not required. Often it's nice to see that the equipment can go just slightly lower, which means that it has a leftover capacity before it starts disoperating. But often you would see mappings just being performed at the set points where you actually need them. So let's just see what in terms of the experience. Knowledge about mapping being the most predominant one, but otherwise we see a lot of internal communication and stakeholder management. Yeah, that seems to be very close to what
Yes.
we often see out there as well. Just the last few questions here. Do you typically correlate control probes or monitoring probes with a mapping probe? So I guess this question is surrounding if you often you would place you'd have a set point temperature for a warehouse, for example, and you'd place a mapping probe next to it. Do you look at how those vary or deviate?
That happens a lot. Areas that are already being monitored and they need to do a mapping, and then we place them close. And they usually don't deviate. They are very close to each other.
Yeah.
So yeah.
I guess points where it could make sense is that if you see a large deviation, it's very likely that if you try to change the set temperature after a while, it might be totally off. And it's also recommended by the guidelines that you place a sensor next to the control sensor in order
Yes,
to roughly verify that the temperatures that the air control system sees are actually also the temperatures in there. And we've also seen a lot of cases where after a mapping, you actually go out and extend the number of control sensors, because it's very clear that the HVAC system, that the temperature that the HVAC system sees, quote unquote, is not the same as is in the room.
Yeah, that
And
happens
you
a
need
lot.
to place more sensors in order simply for the system to operate way more efficiently and have a much better distribution of temperature. Thank you, John. Yes, I've had chambers fail on me. In my experience, coworkers with stability chambers are like chickens running around with the heads up. Well, we're gonna leave that.
Yeah,
That
with
we're
that,
gonna
we're gonna do.
leave that on you. But thank you very much. There are really not that many more questions, but just to round out, thank you very much, everyone, for
Yes,
thank you. A
thank
lot
you.
of great questions. I'll just leave this on here. If you have any questions regarding temperature mapping or monitoring, you can follow us on LinkedIn, or you can connect with either Marcella or I. And you're also more than welcome to reach out to us if you have any questions along the way. We
Yeah,
have
we may be in your facility at
we may
some
be in
day.
your
Yes.
facility very soon.
See you
Absolutely.
soon.
And remember that we have a lot of upcoming webinars, and we have a lot of recordings. There were some questions regarding whether we record all our webinars, and they are freely available on our website. Thank you very much for all the great questions.
Thank you for
It's
everything. Thank you for
absolutely been a
inviting me.
pleasure.